Alright, welcome to Jaka Quantics. Now in this tutorial I'll be putting us through how to measure pad foundations. Right, we've talked about how to measure raft foundation. We have talked about how to measure pile foundation. Now in this tutorial we'll be talking about how to measure pad foundation. Say pad and strip, right? Because they go pari passu. Okay, pad and strip foundation. Now, as our manner is, we normally use our reference document from the NIQS test for professional competence examination. Alright, so we have a sketch here, right, that depicts a pad foundation. That shows a pad foundation. Now, these are isolated footing. You can see them. That's what we call pad foundation. Remember, the raft foundation is the one you have beams, ground beams, and then you fill, and then you come back, and then you do everything you want to do, your reinforcement, and then your hardcore, and then your blinding, and then your slab. Right? So this is pad foundation. So basically we'll be looking at this particular tutorial. Now you can see this section here. Right, this is a section of the block wall here. You can see it. It is a section of the block wall. Right? The slab is 150 mm concrete slab. You can see 150 mm, 50 mm blinding, 150 mm hardcore filling, bed of laterite, 225 solid block wall. Now you can see the depth of the trench. This is semi-coastal. This is the ground level. This tells us the ground level, and down is 950. Right. This is for the single wall, and you can see here why this is for the double wall. This is the double wall here. Look, this section B. So we have two walls here. Right. So this is a section for the double walls. Alright. Now this is a section for the footing. And you can see it here. We have two different footing. One is 15 by 15. Right, the other is 2000 by 15. 2000 by 15. This is 15 by 15. This is 2000 in length, and here the width is 1500. And this is a section for that also. You can see it. Right, this is a slab. These are reinforcements. This is 4Y20. Right, the stirrup is Y10 at 225 center to center. Right, you can also see it here. Now this is the depth. This is the ground level, and this is the depth of the pit. The pit, that's the column foundation. It is 1250. If you add blinding, it becomes 1300. Alright, so basically this is what we'll be looking at in this particular tutorial. So we'll try as much as we can to be a little bit fast and explanatory also, so we don't the video doesn't become unnecessarily too long. Alright, so let's dive into it. So this is basically what we have. And like I always say, you're preparing a takeoff sheet. Of course, you need to put in your parameters, the project title, the drawing number, the BSMM you are referencing. It is very, very important. Now, basically, when you have a drawing and you're just seeing it, and there are other information you think are not there, especially if you are preparing for an exam. If it's a job, you'll be given all necessary details. But if it's an exam and you don't have all the necessary details, you'll be allowed to make assumptions, but you state your assumptions. Alright, so our takeoff list, like I've always said, the takeoff list is very important, especially if you're writing an exam. And if you're going to present your work to maybe your boss or your line manager or whoever is going to check on it, your takeoff list is very important. So it helps you not to miss any item. And the takeoff list is not something you cram. It's not something you cram. Say, I want to carry it off. You have the BESMM4R. It is inside. It is inside the BESMM4R. You have to, as a QS, you must familiarize yourself with the BESMM4R. building engineering standard method of measurement for reverse is the current one. So basically, you see these are takeoff lists here. You see, if there are trees, because if we have a virgin site, right? We have a site. There might be trees. We may need to do some clearing, right? And there might be no trees. And somebody might say, I assume there are no trees, and there are no trees none here, right? But these are just assumptions you make, because if you take your BSMM, if you're following your BSMM4R, it goes step by step. You see removal of trees and site clearance, step by step. So whichever you're not working on, you assume you're not doing this particular thing. All right. So site clearance, site preparation, retaining excavated materials, DPM, that's dam-proof membrane. Then the concrete works, the blinding, reinforcement, reinforced concrete, reinforcement, formwork. All right. So some assumptions that you may want to know, right? Of course, depending on the drawing you're given. Majorly drawings are in millimeters, but when it is not stated anywhere, maybe you have to state it down that okay, you assume all dimensions are in millimeters, and you also assume it's a virgin site. That's when you need to cut trees. If it's not a virgin site, there should be no tree there, holistically speaking. All right, then of course topsoil is 150 mm, but if it is not stated, you just state an assumption. Then reinforced concrete covers 25 mm. If it is stated, use what is stated. Or if it is not stated, then bending 75 mm. If it is not stated, you assume. Then we assume that there are trees there. Say 7 number trees with this particular gate. That's the way it is in the BSMM4R. Alright? So your takeoff list is very, very important. And your assumptions too, they are also important, especially for exam purpose, the written exam. Alright, so we have the excavation and filling is in section 1.5 of the BESMM 4R. Right. Okay. Now we'll see here, removing trees, girth between 500 to 1500 mm. Alright. And after removing, fill holes with materials obtained from site. Is in section 1.5.2.1.0.0 of the BSMM4. It's a number item. I put 1 and then I multiply by the total number. Alright? It's as simple as that. If it's an exam, I've gotten my mark on that one, full mark. Alright, so let's go ahead. And then, of course, after that, you need to clear other portions of the site. Alright, so, of course, site clearance is a square meter item, length times breadth. Kobankaba. To Ankane. So, length times breadth gives you area. That's why it is called a square meter item. And if you come back to the drawing here, this is what we have. This is the length. And this is the width. All we need to do, what's the length? This plus this plus this plus this. Right? Of course, you see the dimension here is at the center here. I have to come out. The dimension is at the center. I have to come out. So half. 2 by half by 1/500. The same thing is applicable here. 5850, 5850. I need to come out. This plus this, then I add 2 by half by same 1/500, because they are 15 by 15 column. We only have two number, 2000 by 15 column. These are the two numbers here. You see BT2. All right, let's quickly come over here so we can speed things up a little. This is addition of everything. That's 23,000. Add 2 by half by 1/500. I already showed us here. Is at the center here. I'm going out. All right, so that gives us back 15. If I add, I have 24,500. All right. Now the same thing goes for the width. The width also is 11.7, like I said here, 2 by 5850. I add ABC as before calculated, or add 2 by half by 1/500. you will get it. That gives me excuse me, 13,200. So it's an area item, 24.5 by 13.2. This is the site clearance, clearing site vegetation and other growth and dispose off site. Right, section 1.5.4.1.0. So I may not be going there speaking and talking about them in that manner. So you just see this is a square. Let me not put it. This is a square meter item. All right. Okay. That is a square meter item. Now the same way it goes for site preparation, that's topsoil removal. Right? This is site preparation, removal of topsoil 150 mm deep. 150 mm. I've already put the thickness, the depth of the excavation of the what's it called? The topsoil. Right? So, and removing from site. When I'm moving from site and now multiply by 0.15, it is now a cubic meter item. You're disposing away from site. That's why you see here multiply by 0.15. I've explained this before, using and to connect different descriptions that has one singular dimension. I've explained this in our previous video also. Right, I can use and instead of me repeating, instead of me doing this and doing it here also, and now you don't say multiply by 0.15. Right, that's what it means. I just use and to connect them. What all it means is you're just trying to tell your examiner that you have a little understanding of measurement and you know how to link these things. That is just what it means. All right. So this is in square meter. Let me copy this. All right. So we go ahead. Okay. Then this is page 1. All right. So now the pit excavation. Okay, having cleared the site, now we'll go to excavation properly. Now, of course, we have pit and we have trench. What I mean pit is the column excavation, column-based excavation. That's what we refer to as pit. And we have the trench. Trench is the one where you have your block wall. Right. Kunjiko. Yowa. Okay. Now, pit excavation, one thing we need is what the depth. What's the depth of the pit? Now let us go over here. This is it here. This is the pit. This is the detail for the column base or the column base excavation. Right, now if you see this scattered line here, it shows ground level, the natural ground level. Every other thing here is above the ground. Alright, so we have 1250. If we add the blinding to it, it becomes 1300. But remember, in the course of our excavation, we have removed topsoil. So you need to put that into consideration. Now let us come over here. See it here. 1250 plus 50. That gives me 1300. Then I remove topsoil. See? To remove topsoil, because I already removed topsoil. So you must not forget that. These are things your examiner wants to see, and even the person that wants to check your work. So if this gives me 1150. So the same thing we'll do for the trench. Okay, let me show right the entire. Okay, this is the pit here. All right, the same thing for the trench. Let's do the details for the depth of the trench also. The same thing for the trench. Let's come over here. This is the trench here. Right. This is the trench. If you can see here, the depth here is 950. Right, this is the footing. The depth from this natural ground here down excuse me, the same thing is applicable here. And also remember, we have removed topsoil, so we need to remove topsoil also. That gives us here 800. All right, excuse me, I want to sneeze. All right, it's not coming. Let's continue. Okay, so for the pit excavation, remember I said it's 1.5 by 1.5. If you come here, we already determined the depth, 1.15. That's 1150. 1150. This is pit base type 1. This is 10 numbers. How do I know it is 10 numbers? Or the bar. Now see it here. This is 1 2 CBT 1 2 3 4 5 6 7 8 9 10. Right? They are 10 in numbers. Alright. Then the same thing goes for this other one. They are just two numbers. 2000 by 1500. 2000 by 1500. Let me call this one here BT2. That gives me 2.00 by 1.5 by 1.15 by 2. Now you need to remember that if you see my waste calculation, they are in millimeters. Waste calculation should be in millimeters, while the dimension column should be in meters. You need to take note of that as a QS. Alright, now for the trench, this is now the trench. The trench, we have both single walls and double walls. That's what the drawing says. These are the double. This is the double wall, right? Or why everything here is the single wall. All right. So basically, we are excavating the trench here, excavating here, here, and here. And of course, you need to understand that there are columns there. Right? There are varying ways to do it. There are varying ways to do it. Somebody might come here and say, okay, let's here. I do this one first. I do them one by one, or I do this one and I multiply by 1, 2, 3, 4. I do this one, multiply by 2. I do this one, multiply by 2. I do this one, multiply by 2. Whichever way you want to go about it, right? Get the answer correct. All right. Let us see now. We want to take everything here and here and here and here, everything, and then we less everything that needs to be lessed. Whichever way you go about it, you are going to get your answer correctly. All right. There's no cast in stone rule to measurements. Nobody should tell you if you do it like this, it means you're a professional. If you don't do it the way you understand it. That is measurement. Do it the way you understand it. Follow the basic principle. Do it the way you understand it, following the basic principle, and arrive at your answer. All right. So this is basically what we have here. This is the single walls. This is remember we've calculated this before. 23,000 by 2. This is this here multiplied by 2, and then I take this here. I multiply by 2. Alright, so this is it. I've taken this multiply by 2, then I want to do my deductions. So you need to follow it very carefully. Right? If you do yours like this, or if you do yours panel by panel, you are right. Do it to the best of your understanding. Following basic principle, you are good to go. And if you want to follow this method, amazing. Alright. So having done this, I've picked everything. Of course, I will come back to this. Right? I need to less bases, because this is my trench. My trench ends here. From here, see my cursor. From here to here is my trench. From here to here is my trench. From here to here. Right? This to this to this, and this and this. I've already done all these bases. You remember? Alright, if you don't remember, please remember now. Alright. Excuse me. Okay, let's do it. All right, so I less this half, right? I've come here. This is 1, 2, 3, 4. That's 1, 2, 3, and 4. Right? And I also need to remove 1, 2, 3, 4. That is 8 bases. Let me take it again. Now I've taken this, right? I want to less the base. Remember, it is center to center. I'm lessing this. I'm coming here. This is 1. This is 1. Right? This edges now. I'm doing the length now. 1. I'm coming here 2. The same thing here. 3. Here also 4 on the length. Now on the width, I have here, I'm coming here 1, I'm coming here 2, here 3, and here 4. That is why you see here 4 by 2 by half by 1,500. That's what I multiplied out here. It gives us 6,000. Right. Then also we need to less this. Remember, I have done this base, I have done this base, I have done this base, this base, this base, this base, this base. Right? So please, you need to deduct it also. So 1, 2, 3, 4, 5, 6, and then 1, 2. So this is 1, 5, 1, 2, 3, 4, 5, 6. That's 6 by 1, 5, and then here 2 by 2,000. Now let us see it here. 6 by 1,500. That gives me 9,000. Then 2 by 2,000. Okay, let me try and explain this again. All right. Remember, I've calculated this basis. See it here. That's what we calculated here. Can you see this? All right. So if I don't deduct them, I will be double measuring. I will be double measuring at this point. At this point, at this point, at this point. So I need to deduct the basis. So remove this, 1, 2, 3, 4, 5, 6. These are the same thing. Then I remove this also, which is 2 by 2,000. So that's why you're seeing this here. Right? We've already done the trench depth already. All right, so we enter it. Total length is this is what we'll have here. 5,400. Why this one is 10,200. So we have 5,400 by 0.69, which is the width, by 0.8, which is the depth we already calculated. All right. Okay. So the same thing goes. Oh, this is the length. Okay. This is that. This is for the double walls. This one is for the double walls. That's this double wall. This just this one. Right? Which is this plus this. Then I less 2 by half by 1,500. That's what you'll see here. 2 by half by 1,500. That gives me 10,200. That's the remaining length. 10,200 by 0.92. The width is different because it's a double wall. It's a double wall. Excuse me. See it here. See, 925. It is 925. That's 0.93. It's 0.93. Right? The depth is 0.8. So this is basically how you do excavation. The excavation for your pad and strip foundation. Right? I hope we get it right. Okay, now let's go to the cutaway. Cutaway. Now I am going to let's do this. Cutaway. Okay. Now you are cutting away soils that have been displaced. What I mean by displaced, remember these pits were not there before. These column bases were not there before. You excavated and you put column base there. So where your base is, the sand there can no longer come back. You cut it away. Where your blinding is, let's come here. Where your blinding is, this blinding. Before, blinding was not there. But now you have put blinding to displace the soil there. You need to cut that away. That's why they call it cut away. Now, the same thing. You see this column here, this top column. This one below the ground. Initially, there was nothing there. It was sand. But now you remove the sand, you put column, stop column there. So it means the sand there before, you have displaced it. You will cut it away. Nuna water. Alright. So that is what cut away is. And again, where you have block. Let's come here. Block. These blocks here. Before there were no block. They were just sand. But you excavated, you put footing, then you put block. So those places where you have your footing and your block, the sand there has been displaced. You'll be cut it away. Alright, now let's quickly work on it quickly. So that I just want to explain that concept. Now, firstly, you see the cutaway, you have to remove excavated material from site. This is the BSMM reference. Alright? Okay. So the blinding to the footing you have to remove, which is 1.5 by 1.5 by 0.05. I'll tell you why you're doing this now. I'll tell you why we're doing this now. There's another ones, another method that you just let me not describe that. It will take time. All right, this is the blinding. This by 10. Then this is the other one, footing 2000 by 1.5 by 0.05. We have two numbers of them. That makes them 12. Now for the trench, the same thing goes. Remember, I've already calculated this trench before with the trench excavation. 50 by 0. This by 0.23, which is the trench footing. See it here. Everything is in the draw. 225. Sherry. Alright. Let's continue. So this is basically what we have. The same thing goes for the double wall. Right. And if you can see, I'm not squaring. I am not squaring. Right. What it simply means, I'm not preparing any bill of quantity. The same thing if it's an exam. If you have to prepare draft bill of quantity in an exam, I've explained that over and over and over in our previous video. Please, so that I don't keep repeating myself. A draft bill, you don't square. You don't square your taking off. Your bill does not carry quantity. It does not carry rate. It does not carry amount. It only carries units. That's a draft bill. Except you're asked to prepare a detailed bill of quantities. Then you have to square. You have to produce maybe fictitious rate. They may not be real rate. You have to square. You have to have quantity. Put quantity in your bill of quantity. You have to carry rate. You have to extend to get amount. And in that order. Show you. Alright. Okay. Now I've removed this. We've deducted. We are cutting away now these soils that are displaced here. And the same thing, the column bases. This is the blinding, the column bases. Now, why this is important is this. By the time I begin to calculate concrete work, blinding, reinforced concrete in base, I don't need to start calculating them again. Just for me to come and pick it from here and paste, copy and paste, because I have taken my time to calculate it somewhere. Excuse me. All right. Now, column base also will be displacing a soil at that point. I need to cut away 1.5 by 1.5 by 0.45 by 10. Yes, it is 0.45. This is it here. See here, 450. That's the base, column base. All right. The same thing goes for the stop column. I already explained that. The stop column, of course, that's the depth of the stop column. 0.23 by 0.23 by 0.8 by 10. The same thing goes for the double wall. Right? So now you see this are concrete work that displaced soils that were originally there. That is cutting away. They have displaced soils originally there, so we are cutting them away. All right. Okay. Now the same thing. I explained that also, that the block wall at that point also has to be deducted, because the block wall has come to displace the soil that was there before. All right. Now this is the girth of the block wall. Now if I calculate this here, this is the girth of the block wall. I do not have to calculate another girth of block wall again by the time I get to that point. That is why it is important to calculate this displacement, or the soils you are going to cut away. It is that important. Right. Now let's see it. So of course this is my block wall. This I less 4 by, remember what we did before, but now I'm not lessing base, I'm lessing walls. No longer base now. Then we did base, but here we'll be dealing with walls, because the block wall is from here. So I'm lessing base now. I'm lessing walls rather, 225, half by 225, half by 225. The same thing I did in the base. 1, 2, 3, 4. That's the length, and then the width 1, 2, and 3, and 4. Right? So just what we did in the base is what we're doing. So we're doing also. Excuse me. All right. So that's what we did here also. Now this gives us the total length of the single wall. And the double wall also, we did the same thing we did, but then we are doing base, but now we are dealing with block wall. All right. So now this is the height of the block wall. That's the wall now below the ground. This is 950. See it here. See from here to here is 950. Right? ILS 225, which is the base. Excuse me. And of course there's a topsoil. I hope I consider that. There's a topsoil. So did minus 225, then it should be minus the top soil. Minus 225. You see, I didn't consider that here. So let me bring this one down. Minus put this one here. Minus 50. Will this stay? All right. Minus 150. Let me put this one here. Plus, that will give me 575. So this is 0.58. 0.58. All right. So that's it. That's I've calculated the block. Right now, why this is important, I'll tell you again. Now if I want to calculate concrete work, I don't have to start afresh, because I already calculated, just for me to go and copy and paste. Now another thing, if this was not to be an exam, right? If it was not to be an exam, cutaway plus backfilling equals excavation. So if it was not an exam that I want to show working, all I needed to do for me to calculate my backfilling, I would have simply said backfilling, that's assuming I'm squaring, equals excavation minus cut away. I don't calculate anything. That will give me the backfilling. Now that's how interesting measurement is. I don't have to calculate, because I'm trying to explain for an exam situation. I don't have to calculate backfilling anymore, because I already do the cutaway. All I need to do, square my excavation. What is the total volume? Remove the cutaway. What is left is automatically your backfilling, because excavation, cutaway plus backfilling should give you your excavation, but because it's an exam, I need to calculate the backfilling also. All right, now we want to backfill. Let me show us what I see. See this place here. You see this trench, this trench. This is the block wall. You see this space here and this space here. That's what we need to fill it up back. That's what we call backfilling. All right. The same thing here. We need to fill it back. That's backfilling. All right. So let's come over here. The same thing goes for the pit. Same thing goes for the pit. Right, I need to backfill here. Now, see here. You see this column? Apart from this column here and the base, every other thing here, I am going to backfill. Every other thing here, I will backfill because there's already a column here and a base, which we have calculated in the cutaway. All right, I hope you are getting the gist. All right, so let's do that. So this is the depth of stop column. This is what we have here. This is the stop columns are columns below the ground. Any column below the ground, they are called stop column. If they are big, if they are very big, if they are bigger columns, like maybe 600 by or maybe 12 by 1, you know those big columns, right? They are called pedestals. All right. All right. So our filling to our stop column. Now the depth from here to here is 1250. Right? I remove 450. I want to know the depth of my fill now. If I remove 450, I must not forget to also remove the topsoil. Let me see if I removed it here. I didn't remove it. Enough. So I have to remove it. Minus. So if you see it, know that I'm removing topsoil. 150. I already put minus, so that's why I'm adding it. That's 650. You get? So very, very important. In an exam situation, that is very important. If I'm working, I may want to overlook it, but in an exam situation, very important. Oh, what did I do here? 1.5. Okay, yeah, that's it. Okay. Now see what I did here. I did it as if there's no column base, and there's no column, stop column, so I need to remove the column here. That's 0.23 by 0.23 by 0.65. The same thing applies to that of the double column. It is 450 by 0.45 by 0.23. Right? This is 0.65, not 0.8. You see, as I see, you cannot count measurement. If you don't know it, you don't know it. Okay. So this is basically what we have. Now also we need to do the same thing for the trench. You remember I showed us for the trench? Here we need to fill. We need to backfill here. So all we need to do is 690 minus 225. That will give me 225 for both sides. The same thing goes for this. So this is basically what we have. Let's see what is this depth? Let us get this depth. I think we did that before. This is 950 minus 225 minus topsoil. Let me do it here. Let me be sure of this. So this is 950 minus 225 minus 150. That's 0.58. This is wrong. 0.58. 0.58. Alright, so this is basically what we have. Alright. So excuse me. Alright, so this is basically what we have for the backfilling and the cart away. It's taking time, man. Alright, so now the earthwork support to phases of excavation, especially when you're working in a place where the soil bearing capacity is low and you are seeing that there might be collapse. You need to provide for earthwork support, right? to physics is an area item, the length times the width or by the depth as the case may be of your excavation. Right, so this is our excavation. The length is 1.5. This is the depth. Right, I have 4 sides multiplied by 10. The same thing here, 2 by 1.15. It goes for 2 sides because they are different sizes. And the next side is 1.5 by 1.15 by 2 by 2. It's as simple as that. See, let me show you what I mean here. Let's come here. Right, this is 1.5. The depth is when I mean depth, how deep it is to the ground is 1.15. So I'm supporting it with wood. So the length by the depth. The same thing goes here. This is different. What this is 2000. This is 1.5. That is why you see it is represented differently. 2000 and then 1.5 by 2 by 2 because each has 2 faces and we have 2 numbers. Okay, excuse me. And the same thing we do for the trench also. All right, okay. So we move ahead now to filling to make up levels. Now, what do you mean by filling to make up levels? Now, if you come here, let's come here now. Now, you see this entire space here, and this entire space here. I need to fill it to a particular level. Maybe I need to put hardcore or imported latter. If the sand I excavated are good enough for filling, I can use them. If not, I can't use them. I will have to import. That's why you talk about imported filling. Konjiko. So I need to fill here. As you are saying, that's the way it is. Length, width, thickness of filling. Length, or whichever you want to use as length. Length, width, or length, width by the thickness of the filling. It's as simple as that. Alright, so this is basically what we have here. So filling to make up levels. I say see the drawings. Right, now the depth of fill 600. Add, oh, this is it here. See, let me show us here. Okay, this is basically what we have here. Right, so if you add topsoil, that gives us 750. Right, so with less slab, then with less blinding, and then with less hardcore. This is basically what we have here. Right. Your filling is above the ground. The filling is above the ground. That's what we have here. That's what we're seeing here. Right? So this is 600 plus our topsoil. That gives us 750. And when we have a lesson topsoil, here now you have to add it, that's 750. Alright? And then we remove the slab. We remove blinding. That's what you're seeing here. And that's what we have here. Remove the slab, remove the blinding, remove the hardcore. That is your laterite filling, the imported filling. See, bed of laterite filling. Okay, so that depth is 400. Alright, now of course we know the length and the width. We already know the depth. This is basically what we have, because it's length times width by depth. So this is what I have here. Excuse me. This is this plus this plus this plus this. Right, I'll add 2 by half by 1.5. The same thing here. Add, oh sorry, I'm coming inside. I will less 2 by half by 1.5. I will less 2 by half by 1.5 here on the length and on the width. That's because I'm coming inside. That's what we have. Let's 1 by half. Let's 1 by half by 1.5. Length. This is the length. Okay, I want to do here first. That's what I have here. 6565 plus this. Aha, I get it. Okay, so this is it. This here, this one first. This is 2000. So I left 1 by half by 1.5 and 1 by half by 2000. Okay, now I get what I did there. The same thing here, but here is different. Here I'm lessing 2 by half by 1.5. This, remember, this is 2000 by 1 by 1,500. So here is I'm lessing 1 by half by 2000. So that is clear there. Yes, that is what I have here. Right. So this gives me this. If I back comment, that gives me 16250. Right. Then for the other side, this, which is this one here, this is 500. I'm doing the same thing. Let's have this before calculated. Here is 1 by half by 1000. Here is 1 by half by 1.5. That's what I have. That's why I see I put ABC as before calculated. All right, and this one also, which is this part of it, which is this plus this. I'm lessing 2 by half by 225 because the width is 2 by half by 1,500 because the width is 1.5. Remember, this 2 column here, this basis here is 2000 by 1,500. So I have this. So this is the imported filling. It is 400 mm thick. 400 mm thick. That's what we calculated. 400 mm thick. All right. So there are ways I can do this. Imported filling, that's the BSMM description. 1.5 by 12 by 2.1.1. Now this is the thickness, 0.4. If I come here and I put 0.4, right, then I remove this one, I am very correct. Now, but because I stated the thickness in the description, I don't have to put it here again. That's why I see here multiply by 0.4. It tells me, I'm explaining that I'm telling my examiner that it is a meter cube item. Of course, you see my unit here is in cubic meter. The same thing goes for this guy here also. It is a cubic meter item. All right. Excuse me. Now I am using this now for hardcore and hardcore. But now hardcore is not 400, it is now 150. If I say no, I don't want to do it like that, and I come here and I put 16.25 by 10.2 by 0.15, and I remove this, what I put here, I am very correct, 101%. Right? Now, however, if I want to go with this, this will not be there. But I'll have it here as a meter cube by 10 by 0.15. Right? I hope this explains it. Now, my DPM, that's the damp-proof membrane. The damp-proof membrane is, of course, you know, the waterproofing you put before you cast. No, it's a square meter item, like we've just calculated. Right. This is 23.3 by 11.93 length by width. This is 23,000. Let's 2 by half by 225. The same thing here. All right. So then our concrete works. I will not be saying anything about concrete works. All right. For blinding, I've explained this before in the previous video, how to measure concrete works. So that not to make this video too long, I'm not going to speak anything about concrete and reinforcement. I have explained that I have taught it in one of the tutorials on the channel. Please go to the channel, look for how to measure concrete works. It is there. Alright, otherwise this particular tutorial becomes too long. The concrete, the reinforcement, the formwork has been explained in one video. I'm just trying to show us just the excavation for a pad foundation is what I'm trying to bring out to us, right, to explain. So please refer to the video, and you are going to see that the reinforcements and everything is calculated. Well, of course, I'll be sharing this template also will be shared, right, so that you can have something handy when you are studying, and you can understand and also ask questions. The comment section is open. Put your questions. The immediately I see it, I am going to respond. All right. So we have this block wall masonry. We have already calculated it before. Right. If you see, I didn't do any calculation. I just went to pick it from where I calculated it. I just went to pick it from where I calculated it, and that is what I am using here. Alright, and of course you just only consider that it is going above the ground now. It is no longer just below the ground, now above the ground. That gives us the depth, the total depth, and that is what I calculated here. 950 add 600. Then remove the slab, remove topsoil, remove footing. That gives us 1025. This is it here. Alright, this plus this. Remove slab. You see where the block work is already. Remove footing, and then the blinding. Go back. Alright, so that's basically how you calculate the block wall. That's the depth of the block wall. So this is 6.6.25, 1.03, 11.48 by 1.03. So this is basically how you measure a pad foundation. Please refer to that particular video for concrete works. Remember, I already told us that the blinding reinforcement, we already calculated it in when we were doing cutaway. The same thing. Just copy and paste what you have done there. Alright, so this is basically how you measure a pad and a strip foundation. How you do the cutaway, how you do the backfilling, the filling to make up level, and everything. Alright, I hope this video helps you professionally. I hope it helps you in your academics. I hope it helps you in your career. Okay, I remember something. Concrete to, that's a very cheap thing, no? The German floor. Concrete to the floor, like length times width times the thickness. Alright, I'll see you guys in the next video. It is Chaka Context. Thank you.